Hello everyone. In this video we're going to be looking at the fraction unit. So let's get to it. Okay, so understanding how auto can help us create equally sized tracks is great and everything, but it has one very important limitation. What is it, do you say? Well, let me answer that by asking you this question. What if you wanted to have one row or column track be twice the size of the other? Maybe you want it to be 3 times the size. With auto, we can't do this. We can only at best make tracks equal size and that's it. With that said, the W3C introduced a new sizing unit known as a fraction. And how this fraction works is that, just like auto, it will attempt to take up the remaining space of the grid container. However, how much space it takes up can be determined by ratio logic. Now, because of this, there will be some mathematics used in this video, but I'll do my best to make the mathematics as simple as possible. So let's get started, and before I write anything, I just want to quickly point out that each grid container in this video is exactly 600 pixels wide, just to make things easy to calculate. So for the first example, we'll once again create 2 evenly sized columns, but this time we're going to use fractions. So I'm going to come over to my selector and I'm going to go grid, template, columns, and this time I'm just going to put 1 and a 1, and this to represent the ratio of 1 to 1. And then after each number we just put FR to represent fractions. I save this, we're going to see we have 2 evenly sized columns, right? And if I open up the debugger and check this out, you'll see that they're 300 apiece, because the overall grid is 600 pixels. So therefore, we have 2 columns of equal width, 300 pixels. Cool. Now we can do the same thing for rows. So I'm going to actually copy this up here just to make things easier on myself. Copy, paste, and we'll add a height here as well. And say we'll go 300 pixels. And then basically I'll go grid, template, rows, and then once again I'll go 1 FR and 1 FR. And when I save this, we get 2 evenly sized rows as well, right? And because the height of the grid is 300 pixels high, each row is going to be 150 pixels high. Okay, cool. So for the next one, I'm going to show you what happens when we use fractions that aren't even, i.e. the ratio is not a 1 to 1. So to do that, I'm just going to type grid, template, columns, 1 FR for the first column, and then we're going to make the second column twice the size. And we do that by using a 2 here. Right? So we're saying the second one is twice the size of the first, i.e. we're using ratio logic. Now if I save that, we now get this down here. Right? So if we check this out, basically it should be 200 pixels by 400 pixels. And it is. Now how you can calculate this is that what you generally do is add the numbers of all the columns that have FR after it together. So we've got 1 plus 2, which is 3. And then we go 1 over 3, so 1/3, and 2/3, right? And that's how much of the space that each column will want to reserve. So because we have 600 pixels here, 1/3 of 600 is 200, and 2/3 of 600 is 400. And that's why you get a column that's 200 pixels wide and 400 pixels wide. Okay, that's how we calculate it. Now we'll do another similar one. This time we'll go 1 to 3. So grid, template, columns, 1 FR, 3 FR. And when I save this one, now we're dealing with 1 plus 3, which is 4. So it's 1/4 and 3/4. So 1/4 of 600 is 150. And 3/4 of 600 is, well, 3 times 150, which is 450. So if I come over and check that out in the window, we can see that we have the first column, which is 150 pixels wide, and the second column is 450 pixels wide. Cool. Now, obviously, because we're using ratio logic, we don't always have to use a 1 to something. We can use 2 to 4 or 3 to 2 or whatever. So I'm going to quickly show that. So we can go grid, template, columns, and we can go 2FR and 4FR, just like so. And if we save this, this is essentially the same as when we used 1FR and 2FR, because if we know our ratio logic, 2FR and 4FR can be represented as 1FR and 2FR. So the result of this will be that the first column will be still 200 pixels wide, and the second column will be 400 pixels wide. Okay? Because if you think about it, it's 2 over 6 and 4 over 6. And 2 over 6 is essentially a third, and 4 over 6 is essentially 2/3. Okay? So that's how you get that. Now, obviously, outside of using just fraction-based columns, we can combine them with fixed-sized columns, like so. So we can say we want the first column to be 100 pixels, and say the second column to be a fraction, right? And when we do this, what you're going to see is that the fraction part of it acts like auto did. So we got our 100 pixel wide column there, and then we've got 500 pixels left for the second column, okay? Similar to what auto does in that regard. Next one, we've got the same example essentially, but we're using percentages. So grid, template, columns. This time we'll go 20% and 1FR. And 20% of 600 is 120. I just know that off the top of my head. So if I come down and check that, we can come to here and see that the first column is 120 because that's 20% of 600. And then basically the 480 takes up the remaining space. Now you can do this for the viewport units. You can do this for the font sizing units and all the other examples we've seen. I'm just showing you a pixel-based and a percentage-based column next to a fraction column. But just know it's available for all. Also, all of these are available for row as well. I'm just simplifying it by just sticking to columns. Now, we can also have two fraction columns combined with a fixed column, and how things are calculated can be a little bit different there. So if I now go grid, template, columns, say 100 pixels again, and I go 1FR, but then I go 2FR, right? What's going to happen here is that we have one column that's allocated 100 pixels of the 600. So therefore, we've got 500 pixels left over. And that 500 pixels is then divided into these two columns. But keep in mind that the second column requires more space than the first one. So how you would do this is that you would go, okay, we're taking the 100 away from 600, so we've got 500. Then you would go, all right, we've got 3. So 500 divided by 3 is roughly 166, I think. All right, so you go 1 times 166. So the second column in this case would be 166. And the second one, the last one, sorry, would be twice the size of the second one. So 166 times 2, it's roughly about 333, okay? So if I now save this, we can verify that. And if I scroll down, we see we've got our 3 columns. And if I hover over, you'll see the first one is 100, like we asked it to be. The second one is, in fact, at 166. It's 0.66, but you get the point. And then the last one is 333.33, so on and so forth. But it was calculated for us on the fly. We didn't have to use percentages to do this. Okay, and that's the factor here, is that we can do this without having to ever use percentages. So that's that example. Now, for the last example, I just want to quickly point out something that may not be obvious to you when you first play around with this, and that is what happens if we just have one fixed column and then a fraction column. So we've seen this example already, just like that. So if I save this and come down, you'll see you've got your one fixed column, and then you've got your fluid column like that, okay, which is the fraction. However, if I change this to like 100 or 1,000 or anything of that nature, it doesn't really have an impact. And it doesn't have an impact because there's no other columns that it needs to calculate the remaining space against, because we already know that that's fixed. So therefore it goes, oh, okay, well, I'll just go as big as possible. All right. So that's the thing just to understand there, that this, when there's one column with a fraction in it, it can be anything it wants to be, because at the end of the day, it's going to just try and grow as big as it can. All right, so that's all I want to cover in this video, and I'll see you all in the next one.